Hi, my name is Dashna Harikrishnan and I am from Group 1 consisting of Aina Alia, Ahmad Yauddin, Divya Lakshmi and Muhammad Saifuddin Khan. And this week we will be presenting about experiment 7, which is estimation of heat and entropy. I will be presenting about the abstract and objective of this experiment. This experiment is conducted to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. In this experiment, heat capacity estimation and entropy generation analysis of heat transfer is performed, in which hot metal is added into a beaker of known volume of water at room temperature covered with aluminium to ensure reliability of the taken data about the temperature change of water. Water in beaker gains heat progressively as heat from metal is transferred to the water, resulting in change in temperature. The temperature change is then measured to calculate the specific heat of respective metals, which allows us to calculate the heat absorbed by water, making it easy to obtain the heat capacity of metals in order to identify the unknown metals. I will pass it on to the next member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Idarif and I'll be continuing with the theory part. Heat capacity of a body is the quantity of heat required to raise the temperature of the body by 1 degree Celsius. When two bodies at different temperatures exchange heat, the quantity of heat lost by the warmer body is equal to the heat gained by the cooler body, and some intermediate equilibrium temperature is finally reached. This is true provided no heat is lost to the surroundings. In this experiment, a heated solid of known mass, m, and temperature is dropped in the calorimeter containing known mass, m2, of cold water. The equilibrium temperature is then measured. The magnitude of the heat lost by the solid must be equal to the magnitude of the heat gained by the water. The formula for heat lost by the solid is mCp T2 solid minus T1 solid. Heat gained by water m2 times Cp times T2 of water minus T1 of water. Cp of water is 4.187 kilojoule per kilogram Kelvin, and at equilibrium T2 solid is equals to T2 water. The entropy change of a system or its surroundings can be negative, but total entropy generation is positive. The process must proceed in a direction that complies with the increase of entropy principle as generation is larger than zero. The entropy generation is a measure of the magnitudes of the irreversibilities present during the process. The entropy generated during this process is determined from delta S equals to mCp ln T2 over T1, and delta S total is equals to delta S metal plus delta S water. And with that, I pass on to the next presenter.
Hello, I'm Divya Lakshmi. Will now present the methodology of experiment 7. The copper metal is weighted using the weighting scale and thus being recorded in table 1. The step is repeated to aluminium and iron metal as well. Then 100 ml of water is being poured in the first beaker. Once the water reaches 100 ml, the water is heated using a hot plate. The copper block was attached with a metal string. The copper block attached to the metal string is lowered into the heated water until it's fully submerged. The copper is loaded inside the water until the water temperature is 80 degrees Celsius. The initial temperature of metal is assumed to be the same as the temperature of the water. 100 ml of water is filled in the second beaker as well. The initial temperature of the water is measured by using a thermometer. Later, the temperature of the water in the first beaker is measured by using a thermometer. When the temperature of the water in the first beaker reaches 80 degrees Celsius, the copper block is immediately taken out from the beaker by using the metal string and transferred into the second beaker that is filled with water. The second beaker was covered using the prepared aluminium foil to minimize the heat transfer to the surrounding. For every 10 seconds, the temperature of water was recorded until it reached a constant temperature. The water was stirred throughout the process to ensure an even heat distribution. The step 2 to 10 was repeated with aluminium and iron metal as well. That's all from me. I'll pass to the next presenter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saifuddin Khan bin Nazaruddin. So I'm going to present to you about the result and discussion. So this is the data that we get from the experiment. So first, mass of water is 0.1 kilogram. The Cp of water is, we know already, which is 4.187, and the initial temperature of metal, which is 80 degrees Celsius. We also have time and temperature of copper, aluminium and iron. So we have to find the specific heat capacity of metal, entropy change of metal, entropy change of water, total entropy change, entropy generated. So we also have the theoretical specific heat capacity of metal, which is copper is 0.385, aluminium is 0.9, iron is 0.444. For the calculation part, the specific heat capacity of metal is equal to heat loss by solid equal to heat gain by water. So mass of solid Cp T2 solid minus T1 solid equal to mass of water Cp T2 water minus T1 water. For the copper, the Cp we gain is 0.530 kilojoule per kg dot Kelvin. For aluminium, the Cp is 1.356 kilojoule per kg dot Kelvin. For iron, the Cp is 0.645 kilojoule per kg dot K. Next, for entropy change, the formula we use is delta S multiply mass multiply Cp multiply ln T2 over T1. So for the copper, the delta S is negative 0.00893 kilojoule per Kelvin. Entropy change for water plus copper, the entropy change is 0.00972 kilojoule per Kelvin. Next, for aluminium, we got negative 0.00764 kilojoule per Kelvin, and for water plus aluminium, the entropy change is 0.00834 kilojoule per Kelvin. For iron, we got negative 0.0102 kilojoule per Kelvin, and for water and ion, entropy change is 0.0111 kilojoule per Kelvin. Is total entropy generated. For the copper, the formula is delta S equal to delta S metal plus delta S water. For the copper, we got 0.00079 kilojoule per Kelvin. For aluminium, we got 0.0007 kilojoule per Kelvin, and for iron, we got 0.0009 kilojoule per Kelvin. Next, we have to compare the estimated heat capacity with existing data given. So for the percentage of error of copper is 37.66%, for aluminium is 50.67%, and for iron we got 45.27%. Next, moving to the discussion, this is the bar chart of specific heat capacity for all the metal, which is copper, aluminium and iron. And the first discussion is about the total entropy generated during the above process. The total entropy of the system is either increase or remain constant in any process. It never decreases. If a reversible process occurs, there is no net change in entropy. In an irreversible process, entropy always increases, so the change in entropy is positive. This experiment have the positive value of the total entropy for all the metal because it is due to the error that occur. It should be zero because this process is reversible. As an example, the temperature of the water will be decreased as the time increases and the metal still can be heated back. Discuss the source of error and method to minimize the error. The error that we find in this experiment was parallax error when taking the readings of thermometer. Next, 100 ml of water were not measured using cylindrical measurement. Lastly, the beaker was not fully isolated, so the heat will lost to the surroundings. The method we suggest is make sure the eye is perpendicular to the thermometer when taking the readings. Next, you use cylindrical measurement to measure 100 ml of water. Lastly, make sure that the beaker is fully isolated. Our next discussion is the justification on the importance of stirring the water in the container. It is very important to keep stirring the water when the heat transfer occurs. The heat lost from the metal also can be transferred evenly in the container. The water that near to the metal will become warmer than the water that far from the metal. By stirring the water, all the water will move and make a contact with the metal, so that the temperature of water are all the same in the container. Therefore, it will increase the efficiency of the heat transfer. Our last discussion is on justification on the importance of transfer the hot metal quickly into the water. The hot metal have a higher heat energy than the air in the surroundings. So the metal will transfer the heat energy to the surrounding and become equilibrium state. But this experiment is to transfer the heat from metal to the water so that we can calculate the specific heat capacity of the metal. By transferring the hot metal quickly into the water, it can reduce the heat energy lost to the surrounding and give us more accurate value for the specific heat capacity of metal. So that's all from me. Next, my friend will present about the conclusion.
Hi, Assalamualaikum and good day to everyone. My name is Aina Alia bint Abdullah and I will proceed to the last part of the experiment report, which is the conclusion. So, to conclude, various substances absorb heat at varying rates owing to a variety of structural variables. The heat loss of the warmer body equals the heat gain of the colder body, resulting in an intermediate equilibrium temperature. This is true as long as no heat is lost to the environment. Based on the findings of the experiment, the heat potential of copper, aluminum, and iron has been determined. Aside from that, while the total entropy generation value cannot be negative, the entropy changes in the system might be positive, negative, or zero. Total entropy is higher in aluminum and iron than in copper. The practical result differs from the theoretical values owing to several probable mistakes that happened during the experiment. That is all from us, Group 1. Thank you.